Good morning, students. I am Pramod Joy, your computer science teacher, and today in this video we are going to discuss about recursion from the unit number 1, computational thinking and programming 2. Shall we start? Recursion refers to a programming technique in which a function calls itself either directly or indirectly. Below an example is given in which you can see define that function a, and in that a, inside a, that same function is called. That is called recursion. A function is said to be a recursive function if it calls itself. There are two types of recursions, or the recursions can be classified mainly into two, and they are direct recursion and indirect recursion. If a function calls itself directly from its function body, it is called direct recursion. Example, the same as the previous one. If a function calls another function which calls its caller function, then it is called indirect recursion. An example is given below. The define A. Inside that a function B is called. And what about the function B in which A is called? That's called indirect recursion. Recursion is a technique for solving a large computational problem by repeatedly applying the same procedure or procedures to reduce it to successively smaller problems. A recursive procedure has two parts, recursive case and base case. In a recursive case, a function calls itself many times during the execution of a program. Any condition where a recursive function does not invoke itself is called a base case. Every recursive function consists of one or more base cases and a general recursive case. If there is no base case, or if the base case is never executed, an infinite recursion occurs. An infinite recursion is when a recursive function calls itself endlessly. An infinite recursion can happen in one of the following cases: base case not defined or base case not reached. Right or sensible recursive code is the one that fulfills the base case and the recursive case. An example, our very first program, a recursive function that computes the sum of first n numbers. We can directly go to that main program first. N is equal to integer of input of enter the number. We have to enter a number. That means the limit we have to enter. And that function is called S is equal to sum of n. That means the control of the program is shifted to that particular function called sum. And in that function, if n is equivalent to 1, then return 1. Else, return of n plus sum of n minus 1. That means that function is called again. That sum function is called again. That means it's a recursive function. Program number 2. Recursive function to print the string backwards. That means to reverse a string to the main program. S is equal to input enter a string. We have to enter a string. And n is equal to length of that string. And now we are going to call that function called reverse. Reverse of that string, comma, length of that string minus 1. That means n minus 1. Now to the function. In that function, if that length of that string, that means n, here it is n minus 1. N minus 1 is greater than 0. If it is greater than 0, then it will print the last character of that string. And after that some space will be there. Then reverse, it calls that function again. Now reverse s of n minus 1. That means the recursion happens. It goes till the second last one or till the last one. And when the value of n reaches 0, that means 0 is greater than 0, no. So to the else if part. If it is equivalent to 0, then print the last character. That way it prints the entire string in a reverse manner. Program number 3. And this is a recursive function to find the power of a number. Example program number 4. Program to find the factorial of a number using recursion. Differentiating or comparing iteration and recursion. In the case of iteration, when a loop repeats, it uses same memory locations for variables and repeats the same unit of code. But in the case of recursion, instead of repeating the same unit of code and using the same memory locations for variables, fresh memory space is located for each recursive call. In the case of iteration comparatively run faster and use less memory space. But in the case of recursion, because of extra memory stack manipulation, recursive version of functions often run slower and use more memory. Now in the case of iteration, it makes a solution less costly to implement, but it will be lengthier. In the case of recursion, it makes a solution look shorter. Program number 5. Program to find the Fibonacci series using recursive function. Program number 6. Binary search using recursion.